How's it going, everyone? My name is Eddie. I am a UTA for this class, and I'm creating this video to quickly go over the Java scanner. Um, this is how you get user input from the terminal in Java, and it's a little bit less abstracted than Python. In Python, you just have the one like input function, which makes things really simple. Java, you gotta kind of think of it a little differently, but it's not too bad. And if you kind of think of it like the way I will cover here, it'll make more sense. So here we have an example of some code. This is how you create a scanner, by the way. You say scanner input, or you can call it whatever, equals new scanner. Notice how I'm passing in when I'm creating this object system.in. This is because I want the scanner to observe system.in. System.in, you can basically think of like the terminal itself. It's like the entity representing the terminal. So in this graphic, think of system.in like this box right here. Um, So yeah, this is saying that scanner is observing the system.in. And say the user inputs this line right here. This is user input into the terminal. This is what system.in will look like. Now I want you guys to think of scanner like a little Pac-Man right here. And Pac-Man will always spawn in right at the beginning of like the first line of system.in, right at the beginning of system.in. And what Pac-Man does in the game is what he'll do here. He'll eat stuff. So what do I mean by that? Let's just say we want to store in a string what that user inputted, right? So we say string x equals input.next line. What next line specifically is telling our Pac-Man or our scanner to do is to start eating until it reaches the end of the line, and then wait at the start of the next line for further instructions, or just wait at the start of the next line until we want to call another next command. So as you can see, Pac-Man was here, and then we told it to eat the next line. So eat until the end of the line. So it did that, and then it's gonna, from what it ate, it says, oh, I ate. This is user input. So now it'll get past this variable x, and x equals this is user input. Okay, so this is right after that code bit executed. Notice how Pac-Man is waiting here now. He's not gonna wait out over here. He's going to go to the start of the next line and wait future instructions, which we gave it right here. String y equals input.next line. So if you notice, there is no next line actually, because the user hasn't inputted anything else. What Pac-Man isn't going to do is just return nothing. Like how it works in Python, our scanner is going to wait until the user inputs something in this next line. So currently Pac-Man is waiting. If the user were to input this string right here, user input 2, now Pac-Man is going to be like, hey, there's something to eat now in this line. I can execute this order you gave me to eat up until the end of the line and return what I found. So after the user inputted, he's going to be like, oh, I found something to eat, and then eat the line. He ate the line here. Now y equals user input 2, which was inputted. And I don't have it in the next slide, but always remember Pac-Man, after calling in next line, will move to this third line here, or at the beginning of this third line, and wait for further instructions. Okay, now so a lot of this was pretty similar to what you might have imagined from coming from Python, but here's where maybe you might come across some differences. In the autograder for the assignment, how it's going to work is the autograder, you might think that it'll input things one at a time, like how a user would input like one at a time in each line. It's actually going to paste the whole thing all at once. So, which adds a little bit of complexity of how to deal with it. But fortunately, with this Pac-Man analogy, it's not too bad. So let's just say this is a completely new program, by the way. I'll create a new scanner, system.in. And say the user inputs all of this at once. So maybe they copy this from a Google Doc. It's 3 separate lines. They pasted it in. And this is what system.in looks like. Now, Pac-Man is faced with these 3 lines. So with these 3 lines, it makes sense to call 3 next lines, right? So here we go. Let's execute the first one. Again, the first next line is telling Pac-Man from where you are, eat until the end of the line, tell us what you got. This is user input. And then it'll wait at the next line for further instructions. The next instruction is to next line again, eat that line. eat until the end of the line from wherever you are, and return us what you got. Okay, I got this string with multiple lines. Uh, Again, after this call, always remember that Pacman will be waiting right here at the start of the next line for further instructions whenever you call next line. So we just executed this, and now it's awaiting further instructions, which it will execute the last instruction, another next line call, and all of the variables are defined. And also notice Pacman is waiting here at this, I guess, non-existent line, waiting for further instructions. If we were to call another next line, again, Pacman will wait until you input something because there is no next line, therefore nothing to eat. So it'll wait until it gets something to eat. So pretty simple. Here's the synopsis of next line. From where Pacman is, read until it reaches the end of the line. After it reads, be ready to read the next input from the start of the next line. All right, makes sense. What if things you want are all in the same line? Like maybe these string of numbers. If you try to call next line here, you'd get 1 space 2 3 space 4, which is not really useful unless you like parse the string or something. But what if we want to make our lives easier and we want these as separate, maybe like variables? So this is where methods like next int, next double, or next come in handy. Let's just look at this simple example. The user inputted this one line, which consists of 4 numbers. 1, and here's a space that they put in, 23. Here's a space they put in, and then 4. And let's say we created the scanner. We call this new method nextInt 3 times. So nextInt is a little different from nextLine, but again, it's the same idea. It's saying from wherever Pacman is, read it until the first, and this is by default, the first white space, or the first space that it sees. And whatever it found until it ate up to that space, return that as an integer, or return whatever integer it found. And then at that white space, stay there, wait until further instructions. So when we call this first nextInt, Pacman will eat until it reaches this space. And then it'll return the integer that it ate, which is 1. And remember, Pacman will wait here and wait for further instructions. It's important to remember Pacman won't reset to the beginning. He persists in his location wherever he is. So we call the second nextInt. He's going to go to the first white space. So he's reading. Oh, there's a space. He's going to stop there. He ate 23, num2 equals 23. And he's going to stop at this white space until further instructions are given. And finally, again, same thing. num3 equals 4. And now Pacman is waiting at the end of the line, waiting for further instructions to start eating. So maybe if we inputted more stuff at the end of this line, Pacman would start eating. But as we'll cover in the next slide, usually once the user inputs this first line, we'll start entering more numbers on maybe another line. But these nextInts, nextInt, next double, next methods cover that for us. So here's the synopsis of these 3 methods. The reason why these are together is all 3 of these methods use this schema of instead of reading the whole line and then starting at the next line, it reads up to the first white space. So that way you can interact with stuff on the same line. They're slightly different though. Next will return what it read as a string. nextInt will return what was scanned as an integer, and then next double will return what was scanned as a double. Quick note, if nextInt, you give it a string or an incompatible type, or next double, it will raise an error. So be sure you're using the correct form of these for the correct purpose. But anyway, from where Pacman is, read until, and again, this is default behavior. You could set the delimiter to anything, but most of the time you want to use a space until it reaches a space or the end of a line. The reason I say end of the line is if Pacman reads the whole line and doesn't find a space anywhere or anything, for example, maybe we had just 1, 2, 3, 4 without any spaces. It's not going to keep reading line by line by line by line. Once it gets through the whole line, it's going to give up, right? And then it'll stop scanning, return what it gets, and start at the next line and wait for the instructions. So Pac-Man will be ready to read input from where it left off, from where the space is, like maybe it left off here. Or if it read the whole line and couldn't find anything, it's going to wait at the start of the next line, right? So there we go. These four methods, next line, next int, next double, are basically what you're going to need for the assignment. If you understand this Pac-Man kind of stuff and how it reads in user input, you should be in good shape. One more side note, and again, I'll cover a real world example or a real code example in IntelliJ here in a second, but you should never really use two scanners or multiple scanners. One, like logically, if you think about it, system.in is just like one entity. You only have hopefully one terminal for your program. So if you have two scanners, it's like you're observing the same one entity with two separate things, which is like one super hard to keep track of. Like imagine you had two Pac-Mans that are like eating the stuff like at once. That's going to be really hard to keep track of, and most likely you'll run into some errors. So yeah, for that reason, stick to one scanner. And again, with two scanners, you'll have this like buffering error, which I'll cover in a second and explain, which could lead to more issues. Yeah, so here I'm going to jump into IntelliJ and show some examples. All right, guys, here we are in IntelliJ. I'm going to start off our first example, delineating that point with like the buffering error. So here we created a scanner, and then we're going to scan in three doubles. And the issue is going to come when we try to make another scanner and scan in a fourth double. Let me explain. So let me rerun the program. Okay, so I just pasted in this string all at once. I didn't click enter yet, so it didn't run. So we have 5, 10, 15, 20. Now, what we learned from the scanner is that, so this first scanner is going to start at the beginning, and then this next double is going to read the first 5. The scanner is going to be here. Then this next scanner call will scan, it'll eat up to the next white space, so it'll read in this 10. Our scanner is currently here. And we call it the third time again, it'll read in this 15 and end here. So we assume N1 will equal 5, N2 will equal 10, and N3 will equal 15. Now here's where the trouble will come in. Intuitively, you think if maybe you created this other scanner, yeah, like maybe if you created this other scanner, it'd end up here because these three were already scanned. And then when you say N4 equals input to dot next double, it's going to read in 20, and then N4 will equal 20. And then the program will terminate because we got all the next statements done, and then we'll print 1, 2, and 3. I really should include system.out.println N4, but I forgot, so it's okay. So that's what you'd expect, but when we run it, as you can see here, we didn't get the exit code. The program is actually still scanning. We're actually right here right now, where it's still awaiting the next double. So if we input another double, the program will end. So we had to input 5 numbers for 4 scans. Now, why is that? The reason is like when these first 3 next statements were run, the scanner is here. This next like 20 is actually what is called buffered, or like think of it like looked at by this next scanner. Like the scanner is awaiting to look at this next 20. It basically reserved it, right? So this is where the issue stems from. When we created the other scanner, we want it to like start here and then be ready to read this 20. But scanner 1's saying, no, I'm already looking at this. Yeah, like you don't have to look at this. I'm already reading this. I already have this reserved. I have this buffered. So input 2 is actually gonna be like, okay, it's already reserved. I can't go there. It's gonna actually start at the end of the line. So that's why we had to input another double, because this second scanner is waiting at the end of the line. And as we learned, if there's nothing to eat, then it's gonna wait for us to input something to eat or scan in, right? So guys, when you're creating scanners, always use one scanner. So if we do this, and let me create the fourth one. This will run, oh, my fault. If we inputted the same string we had before, it'll run normally. So moral of the story, don't create two scanners. Um, yeah, don't create two scanners. Um, Now I'm just going to quickly go over one more example, convert all these to strings. This will be an example of next lines. So instead of next double, let's convert this to next lines. Maybe this will um, somewhat simulate what's going on in your lab. So let's do this the intuitive way. So maybe this is what you're used to in Python. Um, we input like 4 things one at a time. So right now we're at this next line. It's awaiting the next line. Input wow, and then wow 2. We're waiting here right now. If I click enter, scanned it in. And the scanner is waiting up for us to input the next line, wow 3, and wow 4. All right, that makes sense. So if you thought about it through the Pac-Man analogy, the Pac-Man started here. Before anything was inputted, it was waiting for a line to eat. We submitted wow, it ate it, then it waited here. We inputted wow 2, it ate it, and then it waited here, and so on and so forth. So that's pretty intuitive. But I'm going to show you guys that it works for something else here. Let me copy and paste a string I have in a Google Doc from over here. Okay. So that's cool and all, but this is how the autograder is going to do it. It's going to basically paste everything all at once like that. And as you can see, it'll still work because, like from the example, the scanner will just proceed line by line. Each line by line will be eaten by these 4 next lines. And we'll have business as usual. So just keep in mind, that's how the autograder will do it. If you're testing your own test cases, I recommend opening like maybe a Google Doc and then maybe writing them line by line, like the example input, and pasting it all in at once, just like this, to really simulate what the autograder will do. And maybe one more example. This should be primitive. I'll show you guys that if we did next double, if we put like the doubles each on their own line, it'll kind of behave like next line. So like this. I'm going to go back to my Google Doc, and I'll just do this. So we had these 4 next doubles. If we paste it in 4 doubles like this, again, it'll do the same thing. That's because, as we learned, next double will wait until we see the first white space. If there's no white space to be found before it reaches the end of the line, it'll just give up and then start at the next line and wait for the next input. But yeah, that has been the scanner method. Hopefully this will be helpful in completing that first assignment. I know it uses it pretty heavily. Yeah, if you just think of it through the Pac-Man analogy, it should make a lot of sense. So I hope you all have a good day, and thank you for watching.